Hi, I'm Mr. Jake Gordon and I'm going to be showing you a Little Man Computer simulator that I've built. You may be more familiar with simulators like this, which have 100 different memory addresses and each one can store a denary number up to 999. My simulator uses binary instead, so we have just 32 memory addresses and each one can store a number between -128 and +127. Those of you familiar with 2's complement will understand that this is a way of holding a number including positive and negative numbers using just 8 bits. One of the reasons I've chosen to make this simulator using binary is so that we can visualize the different bits which are flowing around the buses. Here's a sample program which is written in Little Man Computer or LMC assembly code. It's using some of the 11 mnemonics available. So in the LMC instruction set, there are 11 different instructions, where one of those instructions is just to put some arbitrary data. And here we're using a few of those instructions. For example, the first one is an add instruction, and then we're going to output a number. I'm going to click assemble and run. In the simulator, we can see, we can pause at any time by clicking on the simulator, and we can see zeros and ones flowing around the CPU. This is one reason why I chose to make it in binary. We'll notice that we can step back and we can step forward using these controls, and we can also speed up or slow down our simulation, and we can choose to have it pause at different parts of the fetch, decode, execute cycle. I'm going to set the speed to 5, and I'm going to press assembler run to rerun the program. Over here on the right hand side, this is where our program has been put into memory. So if we look at this first line of assembly code, at the beginning of it we've got a optional label. In this case we've labeled it A, and this is an add instruction which we can look up in the instruction set, and that says it adds contents of the memory address XXXXX, which is the end of the instruction, to the accumulator, which is the register shown on the CPU on the left. So when the simulator looks at this instruction, we have the 1 at the end. This is the label which takes us to this line, and that's storing the number 1, as we would expect, as we've labeled it with 1. Later in the code, we have a BRA, which branches always to a memory address, and that's going to branch to a memory address labeled A, which is the first memory address here. So this is going to create a loop between the first line and the branching line. When we run the code, we can see that it keeps on outputting forever. You can, of course, write your own program in here, and once you've changed the program, you just press assemble and run to run your program. Thank you.